let's look at page 4. I want to get into complex numbers. So page 4, complex numbers. A complex number is a number written in the form a plus b I. So this is actually something we were just seeing on page 2 when we were getting those answers of 1 plus 0i, for example. A is the real part. It's just a normal, regular number. And B is the imaginary part. Okay, so an example could be something like we were seeing before. If I have -1 plus 0i, that does technically have a real part and an imaginary part. Okay, we could also have something with other values. We could have 9 plus 3i. These values can be any numbers. They don't have to be ones or zeros. There could be any coefficients. They could have any signs. But it is broken up into a real number, 9, and an imaginary number. Okay, so for adding and subtracting with complex numbers, it's actually the same process as we would have done with any real numbers. First step is you're going to distribute only if there is something that you need to distribute. And then combine like terms. Okay, so if we look at number 1, for example, there's nothing to distribute there. It's just a positive in front of here, a +1, so nothing really to distribute. And there's nothing in front of the first set of parentheses. So we can just go right ahead and combine like terms. So when we're doing that, our real numbers are going to get combined, and then our imaginary numbers. And we're doing that exactly how we would with any other type of numbers or values. We need to be paying attention to the signs. This is -11 plus 9, which gives us -2 for our a value, the real number piece. And then we have +3i plus 2i. This is just like if this were variables with x's. This is going to give us 5 i's. We are just adding and subtracting right now, combining like terms. We do not change exponents or variables. We are only adding or subtracting the coefficients here. Okay? Now, number 3, I want you to look at that and think about what is the only difference in this problem. It's subtraction. So there is technically a -1 here that needs to get distributed first. So this problem does become 7 minus 2i minus 2 minus 6i. And now we can combine our like terms. So we have our real numbers. 7 minus 2 is 5. And then we have the imaginary part. -2 minus 6 is -8i, right? We are not changing the i. We're not making it an I squared. They're not canceling out. We are really just counting how many of them do we have. So we're doing -2 minus 6. Okay. The one last skill I want to look at with you guys is on page 5, multiplying. And this is going to be probably the skill that you'll see the most with complex numbers. The critical skill that we need to recall here is we need to remember that I squared equals -1. And I told you guys before to star that, circle it. This is going to be the one that we're going to see the most. So in number 5, this is a distributive property problem. And when we're distributing, we are multiplying. 2i times 8, well, 2 times 8 is 16, and I is just I. And then 2i times -3i, well, 2 times -3 is -6, and I times I is I squared. So I'm done now with the multiplying piece, but it's not simplified all the way because I do have a power of I here. Any power of I needs to be simplified. Now, we just said that I squared is really -1. So what that leaves me with is something that I can multiply. So 16i can't simplify, but negative 6 times negative 1 becomes a positive 6. And now the last piece is they want it in simplest a plus bi form. So we just want to make sure that our real number is first, so it's a positive 6. And then our imaginary piece is positive 16i, so that comes second. Okay, so a plus bi, that's like standard form for complex numbers. The real number first, the imaginary number second. Okay, one more example I'm going to do with you guys is number 7. Now this is also a distribution problem. However, it's a double distribution problem. 7 times 4 is 28. 7 times negative I is negative 7i. I times 4 is 4i. I times negative I is negative I squared. Now we need to simplify this. This is really negative or minus, and I squared is negative 1. Well, doesn't minus and negative really just become plus 1? So this gets simplified to a plus 1. And now we need to get this in standard simplest a plus bi form. So the real number piece, we have 28 plus 1. That's leaving us with a 29. And then for our imaginary piece, we have negative 7 plus 4, which is negative 3i. Okay, so I know we just went a little bit quickly through these, but the main skills that we want to focus on is that when we're simplifying any power of I, so a regular I, there's nothing to simplify, right? But as soon as you have an exponent on that, it needs to get simplified. Okay, we're never going to leave our answer with any power of I. And the main one that we're going to see is I squared becomes a negative 1. So we do need to pay really close attention to our signs, because this is negative 6 times negative 1 here, for example, which we were able to simplify to get a positive. Here, this was minus I squared, so it became a minus negative 1, which ultimately became a plus 1. Okay, so what I would like you guys to do now is I did ask you to finish page 3, number 8. And then I also want you to do on page 4, number 2, 4, and try 6 and 8 on page 5. Okay, so on page 4 and 5, I want you to do these 4 problems. All right, tomorrow we're going to pick up where we left off here. We're going to quickly go over those powers of I again. We'll look at the calculator. I want you guys to come into class tomorrow with any questions, like what are we still not getting? I know this is a new and abstract concept, so this is why we're getting back to videos, so that we do have more time in class for questions. Okay, also keep in mind that your topical review for Unit 2, the blue sheet, is due Friday, so hand that in. The sooner the better, because then you can get started on the next one. All right, and that's it. There is no extra help tomorrow on Wednesday, May 1st. I have a meeting, but there will be extra help on Thursday, so I'll see you there if you need it. All right, bye guys. Have a great day.